tie a string, then you should give a jerk. So therefore the book's maximum, we preferred it like this here. Let me directly straight away analyze it. So where is this? Exactly at a certain point above the center of mass. This is rough. Just after impulse, what will happen here? The body will acquire linear velocity and also angular velocity. Let's see what is the velocity of point P here in this case. Now what is J is equal to mv naught. J into R by 2 is equal to IC omega naught. So J into R by 2 equal to mr square by 2 omega. So in fact, J equal to mr omega, and this is from here. Then oh, what is the velocity of point P now? Velocity of point P is V naught minus R omega naught. So what happened now? Immediately it attains pure rolling. So therefore we know threshold point. Can you remember threshold point? So what is the threshold point? The rolling friction will be zero when you apply force. Similarly, the impulse when you act, immediately it attains pure rolling. Similarly, for solid sphere, 2r by 5. Say snooker game, not that easier. Of course, sometimes some of them will go for every 1 week. They'll go play. Okay, you are playing for fun or enjoyment, nothing. But if you really want to become a player, what happens? You should know all this. If you strike the ball exactly at the, I think snooker will not be the disc. Solid sphere will be there. Sometimes a need arises. What type of need arises? A need arises where it should immediately attain pure rolling. So I should strike exactly 2r by 5. Sir, will they give any scale so that I can do marking? It's not a disc, a solid sphere. So the particular player, what when he should have an idea that I should strike somewhere here, 2r by 5. Above, below, what will happen? He must have all these ideas. Depend a situation arises where he should have a forward slipping the snooker ball after striking the cue, or it should have backward slipping. Sometimes it should have pure rolling. So therefore, you should strike at different point. That's why you see the snooker game. They will strike at different points in different situation. The reason is this one. We don't understand only until if you have a rolling motion idea, then you come to know. Somebody's playing snooker game, and if you visit, no, do make observation. Don't just clap and come, or don't eat any samosa or some snacks will be there. Please do. I think I don't know because I'm multiplex is there or not. I don't know. So if it happens for you, play the game to see that you strike at different points, see what will happen. Or else you do one thing: take some snooker ball or say hockey ball or cricket ball. It's also can take it. And then you take one rod, iron rod. Try to strike it at various points. See what will happen. Okay, now let me shift down R by 4. Let's see what conditions will come. Same thing here. This is this. So it's a pure rolling. Now let's get into no, get into the initially it is a test and there's a rough surface. I think straight away we'll jump into problem like this. No, J into R by 4 is equal to IC omega naught is equal to mr square by 2 omega naught. So J is equal to 2 2r omega naught. 2mr omega naught. Then at the same time, J equal to mv naught. There's a linear impulse that I'll substitute here. 2mr omega naught equal to mv naught. So what we are getting, v naught is equal to 2r omega naught. So what does it mean? So just after impulse, what type of slipping? How to justify? So come for here, draw a diagram. Just after impulse, there's a condition. So what is the velocity of point P? Will be forward, no? Because V naught is greater than omega. So shall we put forward slipping? No. Look at this velocity of forward slipping. This friction module will increase angular velocity, will decrease linear velocity. After some time, we get a situation like this. The same story, say V1, omega 1, still velocity of point P like this, Vp1, and finally it attains pure rolling. No, my conclusion is only that one. If you apply above threshold point, forward or backward slipping, I'll take you back to all the discussion what we made till now. If you apply, I think the threshold above R by 2 only, the threshold point is somewhere here, the red color mark, let me put it. So if you apply the impulse above the threshold point, it will be backward slipping. Agreed? Got it? No. If you apply at the threshold point, pure rolling. So here shall we put a comment? Let's add comment. Impulse, linear impulse is applied at threshold point. So what about here? Shall we put like linear impulse applied? Okay, fine. No. Where the linear impulse applied? No. Linear impulse below threshold point. Okay, no. In front of you, everything is there. So is it only for this? No, any rigid body. Solid sphere, 2r by 5. About 2r by 5, backward slipping at 2r by 5 for solid sphere. Pure rolling less than 2r by 5, it will be forward slipping. I think you have to solve further. I just shown this much. You have to work out all other calculations. Now the velocity of point P will be 0. Sir, below center of mass, I'll apply it. What conditions will come? There's also point to be noticed, no? Yeah, anybody? So below threshold point, I'll take it, no? Carefully analyze and conclude it. This is, let me take R by 4. The impulse is acting like this. No, get into the problem. What happened? Yeah. Let it be rough surface. Initially, let this be disk only. I just confined myself only for the disk. You have to work out for all other different rigid bodies. Radius R. Initially, it is at rest. Just after impulse, the center of mass will acquire linear velocity. And look at omega naught here now. Why I should show like this? Because what is the angular impulse? Angular impulse will act in this direction, no? J into, so this should be equal to, so J is equal to mv naught. J into R by 4 is equal to IC omega naught. Look at this sense. Now what is J? 2m R omega naught. I think there's it's quite very easy, no? Both are in same direction, no? V naught and R omega naught. Both are in same direction, so it will be what? Forward slipping only. At least now can you conclude? For a rigid body, if you apply the impulse at threshold point, pure rolling, above threshold point, backward slipping from the threshold from the threshold point to lowest point, it will be forward slipping only. We are just concluding things. Sir, how to solve this? Finally, what will happen? I think you get back into the concepts we have discussed. Initial angular momentum, you check it. So it may return back, no, or it may come to rest, or anything can happen. So what is initial angular momentum? I think you have to go back to the some point we have discussed. LPZI is equal to initial angular momentum, mv naught r clockwise, IC omega naught anti-clockwise. So mv naught r plus what is this IC? Moment of inertia of the disk. I'm taking clockwise, negative, anti-clockwise. Let me take positive. So this will be mr square by 2. V naught, what you can write? V naught by 2r. Solve it. If you get positive, okay, it will attain pure rolling in forward action. If you get 0, it will finally come to rest. If you get negative, if it is a negative, it will attain pure rolling in forward action. If it is a positive, it will attain pure rolling in backward direction. So minus mv naught r. So this will be mv naught r by 4 minus 3 mv naught r by 4. So I got negative. What does it mean? Finally, retain pure rolling in moving forward direction. Finally, what will happen? So what that friction will do? Will decrease the angular velocity and will decrease linear velocity. At one point, angular velocity will become 0, and further it will make, and it will make it to attain pure rolling in forward direction. I'll just show all the things. Please do work out this, because already we discussed. I'll go for next concept. How do you can say, sir? Because initial angular to what point? We got it negative, no?